In this lab, we will introduce the hardware platform that is going to be used throughout the course. This will be the ST Disco L475VG. We will also introduce the ARM Embed development ecosystem to get you familiar with the development process that we will be following in future labs. This is the ST Disco L475VG development board. We will refer to this as the board throughout the remainder of this and future labs. Let's take a look at the technical specifications of the board we will be working with. We will identify the various hardware features that are present on the board and what their capabilities are. For storage, there is 64 megabit quad SPI flash memory. For connectivity, there is a Bluetooth V4.1 module, a sub-gigahertz low-power programmable RF module, a Wi-Fi module, and a dynamic near-field communication tag. For input and output, there are two digital omnidirectional microphones, a capacitive digital sensor for relative humidity and temperature, a high-performance 3-axis magnetometer, a 3D accelerometer and a 3D gyroscope, a digital output barometer, a time of flight and gesture detection sensor, and two push buttons. For communication, there is a USB on-the-go with micro AB connector. There are Arduino Uno V3 and PMOD expansion connectors available on the board too. The board provides flexible power supply options, such as the ST-Link USB V-Bus or external sources. And there is an onboard ST-Link debugger/programmer with USB re-enumeration capability with mass storage, virtual COM port and debug port. Next, we'll look at the board pinout. But first, let's review some important terms. A pinout is a description of what each physical connection, or pin, does on the board. This legend shows what the various colours mean when interpreting the pin diagram. A header is a term used to describe a set of pins that are physically grouped together. You can refer back to this image if you need help remembering what the coloured labels correspond to in the diagram. These diagrams show the board pinouts. Notice that some pins have more than one function. You can configure these pins in software to do different things depending on your needs. Some of these additional functions are grouped together and require taking over a set of pins, such as SPI or I2C. For example, if you want to use one of the SPI buses, for example SPI2, then pins PD1, PD3, PD4 and PD0 need to be reconfigured from GPIOs to the SPI control lines SPI2 SCLK, SPI2 MISO, SPI2 MAUSI and SPI2 SSEL. In terms of the software required, you will need access to a computer, an internet connection, and you will be introduced to the Embed Studio IDE.